Hi everyone. I wanted to talk to you about assignments 3 and 4 of the molecule project, but before I did that, I did want to tell you about a mistake that I made. On the previous video, I actually put 3 lone pairs on this oxygen atom, and there should only be 2. There's 2 lone pairs and 2 bonds. It was just an oversight on my part. I tried to annotate the video as best I could to show that, but it may not be super clear, so I did want to point that out here in this video. I also want to let you know that this video is going to start assuming you've already watched and done the assignment for the first video. So if for whatever reason you're watching this before you've done assignment 1 and 2 or watched the video for assignment 1 and 2, please go back and watch that first because that's going to go over a lot of the basics of how we get these individual structures. So basically what I've done is I've opened up my assignment 1 and 2, and now I want to continue. I've also opened up the 2 structures that I drew last time, and again, I took out the lone pair here because it should only have 2 lone pairs and not 3, so we fixed that. So I have my 2 structures, I have my skeletal formula and my expanded structural formula. I saved those from last time. Hopefully you did as well. If not, you're just going to want to go ahead and redraw those using the same way you did it before, or you can use the video for assignment 1 and 2. Now what I want to do is open up Blackboard, click on Final Project, and Molecule Assignment and Descriptions. And mine happened to open because I just had it open to Assignment 3, but you want to scroll down to Assignment 3. And Assignment 3 is about chiral carbons and stereoisomers. And there are essentially 2 types of stereoisomers that you're going to want to focus on here. The first one is enantiomers. So if you have a carbon bonded to 4 different atoms, it will be chiral, and it could exist in the R configuration or the S configuration. You could also have E and Z, sometimes if they're simpler molecules, cis and trans isomers of your molecule. So these are both the types of stereoisomers that we're looking for. Now in here, it does say something about calculating the maximum number of stereoisomers only based on the chiral carbons for R and S configurations, the enantiomers. However, if you want to, you could draw the stereoisomers with the E and Z as well. You do need to draw them for sure, but you can also count them in the stereoisomers as well. And I'm going to show you how to do that. In fact, I would really suggest you do count them as part of the stereoisomers because then you'll know how many you need to draw. So let me do this with my example molecule to give you an idea of, what's going on here. At the same time, I also want to show you some of the power of ChemSketch. Here it's good. In a few minutes, when we get to the hydrogen bonding, you're going to think it's not so good, but I'll show you how to work around that problem. So let's take a look again at assignment 3 first, chiral carbons and stereoisomers. So what I'm going to do is I'm going to go to my Word file. This is the exact same Word file that you saw me make in the previous video. And I'm going to type in chiral carbons and stereoisomers. And I'm going to go ahead and center that. So this is my goal. Now what I'm going to do is open up ChemSketch. And in ChemSketch, I have my molecule. So if I click on this structure, I have this selected, I have the box selected. I can go ahead and copy this. I just hit Control C, Control V, and then I can make a copy of it right here. So I'm just going to make a copy of this molecule to show you what's going on. Now what I'm looking for here is 2 things. Double bonds with the possibility of making E and Z isomers. So said another way, double bonds where there aren't all the same substituents bonded to one side. So for example, here at this double bond, I have a methyl group on this side and this carbon containing group on this side. What's not shown here, which I'm going to go ahead and show, is a hydrogen here and a hydrogen here. So this double bond is capable of forming E and Z and also cis and trans isomers. Why? Because it has a methyl group and it also has this other carbon containing group. Now if this were a hydrogen, this would not be capable of forming stereoisomers if these are both hydrogen. But this particular one is. So I need to go ahead and show it. In this case, I have put this in the E configuration. E, in this case also trans, okay, because the 2 high priority groups, in this case the methyl group, and this entire group are opposite of each other. So this is the E configuration, and I'm going to need that. Now, what I want to find is chiral carbons. And this is a carbon bonded to 4 different substituents. So anything with a double bond is not possible. This has 2 hydrogens on it. That's not going to be chiral. This has 1 hydrogen, the group containing the carboxylic acid, the group containing the double bond, and the bromine. This is a chiral carbon. This has 2 hydrogens. This carbon has a double bond. So in this case, I have one carbon that's capable of forming an enantiomers, and it's this carbon right here. So what I want to do first, and you don't really have to do it first, but I'm going to do it first, is I want to draw this again, but I want to make this the opposite enantiomer. So that's basically what I'm going to do. But before we do that, let's think about it. We're going to have 4 stereoisomers. We're going to have one where this is E and this is R. We're going to have one where this is E and this is S. We're going to have one where this is Z and this is R. And one where this is Z and this is S. So you can think of the stereogenic center here as 1 in the 2 to the n formula. And you can kind of think of the middle of this double bond, if you will, as a second point in that 2 to the n formula. So that's basically how you can do this. So that's what I would suggest you do. Do not count this as 2 separate chiral carbons, because you can't do that. If you do that, first of all, it's not exactly correct. But second of all, you're going to find that you're going to need 8 stereoisomers, but you're not, because this only has 2 different configurations, E or Z. So again, I need 4 total configurations, ER, ES, ZR, ZS. So the first thing I want to do, again, is write this in the E configuration, which I've already done. And I've explicitly shown the hydrogen so that it's clear that this is in the E configuration. Now what I want to do is I want to select this thing. To do that, I get this, I grab it, Control C, Control V, and I paste it. Now here, I want to change this to a carbon, a methyl group, and I want to change this to a hydrogen. And I've noticed that ChemSketch is a little annoying because now this doesn't, CH3 doesn't show. So if you want it to show, go ahead and click this. I want to click on just this atom right here. And then if you go to Tools, Structure Properties, and you click All, and you hit Apply, it'll reappear as a CH3. So now I have the 2 different versions. I have the here the E or the trans version where the methyl group and this other large group are opposite of each other. And then I have here the Z or the cis version where the methyl group and this large group are on the same side of the double bond. So I've gotten 2 of my 4. But I've done nothing with the bromine. So in this case, both bromines are not shown in either stereochemical configuration. In order to do that, ChemDraw actually does something pretty useful. I can click this button right here, this RS configuration, and it'll bring up the 2 structures. It'll bring the structure where bromines to the front and the structure where bromines to the back. And I can either select both by hitting Control and highlighting both, or I can hit Insert All. It doesn't matter. I'll select both and hit Insert Selected or hit Insert All, and I insert them. For whatever reason, these molecules went into my case page 3. A minute ago they went into page 2. So they may go to page 2 or page 3, not a big deal, but there are my 2 molecules. Notice that they're still in the E configuration. The methyl group and the large carbon containing group are still opposite of each other, but I have my bromine here sticking out at me and here sticking away from me. So these are 2 different stereoisomers. Now, what I want to do is I want to show the hydrogen. Well, if the bromine is coming out at me, the hydrogen must be going back into the screen. So therefore, I click on hydrogen, I click on the dashed, and I add the hydrogen so it's clear. And now I want to do the opposite here for this one. Now the bromine's sticking out at me, or excuse me, sticking back. So I want the hydrogen to be sticking out at me. So I simply add the hydrogen with the bolded bond here, like that. All right. So now I have my 2 isomers. In a second, we'll figure out which is R and S. Again, it went to page 3 for whatever reason. Now what I want to do is I'm just going to use this to flip over to page 1, and I'm going to grab the other one. All right, now I have this one in the Z or the cis configuration. I click this RS thing, and I click on Insert All. And this time it automatically found the page that it was on. I don't know why it does that, but that's what it does. All right, and I want to go ahead and just select this molecule and just move it a little bit further away. I want to do the exact same thing with the bromine. I want to add the hydrogen, but in this case I want the hydrogen to be back because the bromine is forward. And in this case I want the hydrogen to be forward because the bromine is back. So I just put them in like that. Notice I put them in the same direction. So now I have these two. I want to go ahead, click this, highlight these two, and I want to copy, and I want to go back to the other page, and I want to paste these in. And if you push default, you could paste them in a way like this. I have now made the 4 isomers. Notice that in one case, the top two, these are both in the E configuration, and we'll figure out the R and the S in a second. These are both in the Z configuration, and we'll figure out the R and the S in a second. All right, so that's basically what we want to do. So what I'm going to do is I'm going to take these, all of these, and I'm going to copy them back into Microsoft Word. And now I'm just going to make them a little bit larger so there's some nice spacing between them. And I'm going to go ahead and insert a text box, and I'm going to hit draw text box. I'm going to put a text box in here. I want the outline of my text box to be non-existent, so I'm just going to put it there. So this isomer, as we already talked about, is E. Oops, I don't want it to do that, so I hit Control Z. When I put bracket E, or parenthesis E parenthesis, it made that symbol. If I hit Control Z, it basically goes back. So E, and now I need to figure out if it's R or S. So to do that, I need to rank my priority groups. Well, bromine, this is a carbon, this is a carbon, is 1. So 1 is here. Now, carbon, carbon, double bonded to a carbon, 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 bonded to an oxygen. So here, 2 carbons away, I have a bond to an oxygen, and here I just have bonds to carbon. So this is priority 2. This is priority 3. The hydrogen is away from me, so it's the default configuration. Said another way, I don't have to flip it. So since the hydrogen is away from me, I can just count them 1, 2, 3. 1, 2, 3, as I look here, is counterclockwise. So this is in the S configuration. So this one is E and S. I then can take that text box. Maybe I want to make that a little bit bigger before I copy and paste it, so it looks a little bit better. And I can just hit Control C, Control V, make a copy of it, put it over here. Well, this one is still E because the methyl group and the hydrogen, the methyl group and the large group are still opposite of each other. The H's are still opposite of each other. But this one is in the R configuration. By moving any 2 groups, you definitionally change the stereochemistry. So if this one's S, this one has to be R. Now, I want to go ahead and just paste again. It's the same one. I'm going to pull it down here. Now this is still S, because you'll notice this stereo center is exactly the same. And now this is Z, because it's cis configuration. The methyl group's here, the large group is here, so this is the Z configuration. And then finally, I'm just going to copy that and paste it, drag it over here, and I'm going to put this as Z, that's constant, but this one is R. So in this case, I've now identified the 4 stereoisomers. So I want to put up here 4 stereoisomers. All right, notice that the double bond only leads to 2 different ones, E and Z. And I could do a little bit better job to line these up a little bit better and stuff like that. But it gives you the general idea. All right, as far as the chiral carbons, the carbons bonded to 4 different things, ChemDraw will essentially find those for you. Now that I've completed the assignment 3, I want to move on to assignment 4, which involves hydrogen bonding. So all I'm going to do is go down on my Word file. I've saved it already, and I'm going to type in hydrogen bonding. And now I want to just go ahead and center this, and I want to draw hydrogen bonding. Unfortunately, ChemDraw doesn't make hydrogen bonding particularly easy. So here, I'm going to go ahead and just save this so that way I have all this stuff if I need it. And then I'm going to go back over to page 1. All right, and I didn't mean to put that CH4, so I'm just going to hit Control Z. I'm then going to hit this and just get these guys out of the way. So what I want to do is use this structure. I didn't mean to do that, so I'm just going to pull these out of the way again, and I'm going to grab this structure. I'm going to hit Control Z, Control V, and I'm just going to paste it here. Now, I want to get rid of all these hydrogens before I put in my hydrogen bonding, because it's a little bit in the way. To do that, I want to go to Structure, then Tools, and then where it says Remove Explicit Hydrogens. It now no longer shows the explicit hydrogens, so that's a little bit more of a straightforward view. The only thing I don't like is the position of this particular hydrogen, so what I'm going to do is just go ahead and draw it in like that so it looks a little bit better. So you could either use this. If you don't like how this looks, you could grab, I didn't mean to hit that, grab this, grab here, and go ahead and click on this button. Okay, now it shows the molecule like that. That looks a little bit messy to me. So in this case, I want to go to Tools, Structure Properties, and I don't want to show the carbons either. So I double click on that, hit Apply, and now I'm back to the skeletal formula, but I have the lone pairs. You'll notice the lone pairs moved a little bit, so I do have to do a little bit of work, to move them back. I want to try to grab those ones there if possible. Of course it's not, so I'm going to move that over there. Then move this back over here. I'm going to go ahead and just highlight it all again and hit this. And of course it moved again. So you can play with this all day. I'm going to put it back how it was. And basically, what I'm trying to do is get it back to where it was. And as I click through this, it's not finding its way back. All right, so I'm not getting anything I like, so I'm just going to Control Z back through until here, and then I'm just going to move this manually so that it's at least reasonable like that. That looks fine to me. I'm going to expand out this hydrogen just a bit so it's a little bit further away, and then I'm going to move these lone pairs as well, so that they fit on this oxygen. Again, there's only 2 lone pairs on that oxygen. Then I need to move these ones. I need to move the bromine out of the way again, move that over, put the bromine back, and just kind of line this up. All right, but if you want to use the one with the CH2s, that's totally fine as well. You could see that was a little bit of a pain in the butt. So now I have my molecule. I'm going to move my oxygen just a little bit, and you can play with it so that it looks nice for you, but I'm good with this. Now I want to show hydrogen bonding to water. There are 2 things that hydrogen bond to water. They are oxygens and nitrogens. So if you have oxygen and nitrogen, they'll hydrogen bond to the hydrogen of water. If you have a hydrogen bonded to an oxygen or a nitrogen, it will hydrogen bond to the oxygen of water. So that's basically how it works. What you don't want to do is you don't want to put lone pairs on bromine hydrogen bonding. You don't want to put hydrogens on carbon hydrogen bonding. So hydrogens can hydrogen bond, but only if they're bonded to an oxygen or a nitrogen. Nitrogens and oxygens can also hydrogen bond in all cases. So this oxygen can hydrogen bond, this oxygen can hydrogen bond, and this hydrogen can hydrogen bond only because it's bonded to an oxygen. Now if I had an amine and I had a nitrogen bonded to a hydrogen, both the nitrogen and the hydrogen could hydrogen bond. But this hydrogen can't, none of these hydrogens that aren't shown can, and the bromine can't as well. So we need to show the hydrogen bonds of water. Well, it turns out that this is really a pain. So if we look here, I can draw oxygen, and I can bond it to 2 hydrogens like that. And it needs some lone pairs, so I'm just going to steal from these, Control C, Control V, and I'm going to put in the lone pairs. This one I want to rotate, so all I have to do is go to templates, object, and rotate 90 degrees. Notice I am in the draw mode. I'll go back to the structure mode, and I can put it on like that. So what I suggest you do is you draw one water. Now you want to put the waters around the molecule in the appropriate positions. So the first one I want to do, Control C, Control V, is I'm going to put one there, and that water is going to hydrogen bond to this oxygen. Note that the hydrogen bond between the oxygen of your molecule and the water will occur at the hydrogen. So oxygen, hydrogen bonds with hydrogen. So we want it there. I'm then going to hit Control V again, excuse me, and I'm going to put another water here. And this one is going to hydrogen bond with this one. And it doesn't need to be perfectly aligned. I'm just going to kind of show how it is. There is a specific angle for a hydrogen bond, but we're not going to try to figure that out today. All right, so we're going to hydrogen bond these. Notice I'm not adding any hydrogen bonds, and I'll tell you why in a minute. So if I hit Control V again, I can then put a water here, and this one is going to hydrogen bond with the hydrogen that's directly attached to the oxygen. Note again, this hydrogen is not going to hydrogen bond, only the one directly attached to an oxygen or a nitrogen. But the hydrogen in our organic molecule will hydrogen bond with the oxygen of water. Oxygen, hydrogen bonds with hydrogen. Hydrogen, hydrogen bonds with oxygen. We don't want to put an H to an H. We'll also notice that we have two more lone pairs on oxygen that are capable of hydrogen bonding. So I'm going to hit Control V again, and I'm going to put one water here, and then I'm going to hit Control V again, and I'm going to put one water here. Now this particular water isn't lined up real well with this lone pair. So what I'm going to do is I'm just going to grab it. I'm going to click on draw again. It's already on draw. And I'm going to just rotate it a bit so that it's a little bit better lined up like that. So now I've surrounded, if you will, this one is just my template, but I've surrounded my molecule with waters. Lone pairs on oxygen are going to hydrogen bond with hydrogen. Hydrogens are going to lone pair with the, or going to hydrogen bond with the lone pair on the oxygen of water. So I've got it lined up how I want. Now I spent 45 minutes trying to figure out how to draw a dashed bond in ChemDraw. It turns out there's no good way to do that. So what I'm going to do instead is I'm just going to grab this whole structure and I'm going to draw my dashed bonds in Word. So I'm going to copy this whole thing. It looks like a mess, but I'm going to copy it into my Word file for hydrogen bonding. I then want to paste it in. I strongly recommend you resize this thing before you start. All right, blow it up a little bit. It gives you a little bit more room to work, and it'll make your life a little easier. So I blow up my molecule like this. Now I want to put in these dashed bonds. Unfortunately, this is not super easy to do. But what you can do is just go to Insert, Shape, and put a bond or a line. Now I want to put a line between hydrogen and the lone pair like that. But a couple things about this. One, I want it to be black. Two, I'm going to make it a little bit fatter so it'll be easier to see. All right, it's not a lot, but a little bit. And then I want to make it dashed. So if I click on dash type, I can click this or this, it doesn't matter. I'm going to choose that one, but it doesn't really matter. I've now added a hydrogen bond. Now if I hit Control C and Control V, I get another one, and I just move it. So I want that to be about there, and then I want it to go up to here. Then I hit Control V again, I get another one. I want it to be here and here. So I just grab the circles where I want it. Hit Control V again. I'm going to move the whole thing because it's about lined up, and it's there. And then I hit Control V one last time, and for whatever reason I put it way over there. I can then, I'm not sure why it's doing that. I can then put that dot there and line the other one up like that. I now have my hydrogen bonds with water using two different software programs. So I know that's a pain in the butt. So now I can go ahead and be done with the hydrogen bonding. Again, I'm hydrogen bonding to the lone pairs of oxygen and the hydrogen of water, and hydrogens bonded to oxygens or nitrogens with the lone pair on the oxygen of water. So that assignment is all set. Now what do I need to do? Well, the last thing it tells me to do is polarity and solubility predictions. So I'm going to type in polarity and solubility predictions. And I'm going to go ahead and just make that bigger because it's the title. And now I want to draw my molecule one more time. Well, I don't actually need to draw it here because I don't need anything special. So here I can just go ahead and grab the skeletal structure of my molecule that I already have saved. I would again recommend you save this as you go. Having extra stuff, especially when you have multiple pages, is useful because if you ever need something, you can just grab it here and you don't have to redraw it. So you just paste this in, and then we're going to go like this. Well, now I need to determine which parts of my molecule are actually polar. And to do that, I'm looking for essentially oxygens and nitrogens. So in this case, the carboxylic acid portion of my molecule is the polar part. And you can make an argument that an alkyl halide is polar. You can even make an argument that an alkene is polar. But alkyl halides are relatively non-polar. If you look at chloro and bromoalkanes, they're not even soluble in water. They won't mix with water. So here we're trying to figure out, is this molecule soluble in water? Well, the only thing that's really going to help this molecule be soluble in water, in my case, is the hydrogen bonding that we just showed above with the carboxylic acid portion of the molecule. So this is the polar part that I want to identify. I'm going to do this just like I did before for the functional groups. I'm going to insert a shape. I'm going to pick an oval, and I'm going to highlight my molecule. I missed some stuff, so I'm just going to pull it so that I'm not missing as much stuff. Then I go to fill, no fill, and I like it to be black. I didn't mean to do that. Fill, no fill, and I like the outline to be black because I'm going to print it in black and white, so it'll show up well. So there, I basically have highlighted the polar part of my molecule. I can then insert another shape. This time I want a line. I put it like that. I want to make it black again, and then I can insert a text box like this, and I could put polar. I might want this to be a little bit bigger. I highlight it, go over here, can make the molecule, make this a little bit bigger. If I click on format, I can take away the outline so that it's just the word polar, and I don't have the outline like that. I now have identified the polar part of my molecule. Finally, I need to make a solubility prediction. Some of your molecules may be commercially available, but a lot of these molecules that we've chosen are relatively useless. So it's not that they're impossible to make, there's just no good reason to make them. So here, we need to guess whether this is going to be polar or not. Well, what do we know about carboxylic acids? What we generally know is that carboxylic acids with 5 or less carbons are soluble in water. Well, my molecule has 7 carbons. Since it has 7 carbons, it's unlikely to be soluble in water. So what I want to say is something along the lines of, although my molecule has a polar carboxylic acid functional group, it contains, I do not know what's going on here. So I have my text a little bit too low. So, although my molecule is a polar carboxylic acid functional group, comma, it contains 7 carbon atoms. Generally, carboxylic acids with more than 5 carbons, I'm going to type it this way, are not soluble in water. I predict that my molecule will not be soluble in water. So you can write it however you want. Please don't copy my words. They're never even very good. But the idea here is you need to make a prediction and you need to say why. Give some kind of rationale. So my rationale is based on the number of carbons and having only this one polar group. So as I scroll back through here, you can see we did the chiral carbons and the stereoisomers. We found that there would be 4 stereoisomers, E and Z accounting for 2 of them, and R and S accounting for the other 2 for a total of 4. So we have ES, ER, ZS, and ZR. Next, we did the hydrogen bonding. You'll recall that I made the hydrogen bonds in Microsoft Word for the very simple reason that after 45 minutes of trying, I couldn't figure out how to make a dashed line in ChemSketch. So I used Word, saved myself a headache. Then finally, the polarity and solubility predictions. So I labeled the polar part of my molecule. The rest is assumed to be, of course, nonpolar. And then I made some kind of prediction of what's going on. I hope you found this video helpful.